welcome to this video tutorial in which I will be taking you through the answers or how to answer the questions of June 2017 paper, higher paper, that is higher tier of Edexcel Exam Board. So without further ado, let's get started. Right, question number one, we start with it. We need first to find the probability of getting A1. Okay, so in order to do that, we do 1 minus the sum of all the other probabilities, so that is 0.17, add 0.18, add 0.09, add 0.15, add 0.1. Go ahead, use a calculator and do this calculation, you will get 0.31. Okay, so the answer is 0.31. Now to work out the number, the total number of landing on a 1 or a 3, it's going to be probability of landing on 1 first, which is 0.31 times 200, going to be 62. Probability of landing on a 3, which is 0.18 times 200, which is going to be 36, added to 8, 9, and that is your answer. Now for this one, let's exercise number 2. Let's write down the ratio of children or adult to children as a fraction. So let's do adults to children, A for adults, C for children. The ratio is 5 to 2. Let's find the fraction of adults is 5 out of 7, and the fraction of children is 2 out of 7. Okay, now it says here 3/4 children had seats in the stools, and the rest, 117 children had seats in the circle. So those 117 represent 1 out of 4, right? So that is 1 out of 4. So basically we're saying the number of children, let me pause there. So yes, so the total number of children, so the number of children is equal to 117 times 4. Now that would give me 468. Okay, 4 times 7 is 28, 4 times 4 is 1, and 2 is 6, so that is 468. So that's the total number of children. Now that total number is equal to 7th, right? Represent 2 out of 7 of the total number of children and adults. Okay, so basically we need to work out 7 out of 7. Okay, so basically we're going to do, I do 468 divided by 2 to work out 1/7, right? And that gives me 234, and of course multiply by 7, right? Total number now is equal to 234. We times it by 7, because from this, according to this ratio, we've got 7 parts. Okay, right, so that is giving me if I did that with our calculator, I know it is a calculator exercise, but at the moment I don't have a calculator, so that is 1400 plus 210, 30 times 7 plus 28, that gives me 1638. 1638. That's the total number of children and adult. Okay, now a question is, says here, on this Saturday were there people on more than 60% of the seats? The number of seats is 2,600. So let's go find what is 60% of that. Well, 10% is 260. So 60%. It's going to be, if I multiply by 6, this one here, so 260 by 6, that gives me 1,200 plus then 60 okay, which gives me 1560. Now you can see my total number of adults and children on that Saturday is greater than 1560. So yes, the answer is yes, it is more. Yeah, it is more than 60%. Right, so that's the answer to question 2. Next is question 3. Right guys, question number 3 is a question on plan and elevation. This is the front drawing here. They want us to use this scale, means 1 meter is represented by 2 centimeters. So therefore I need to have 4 centimeters for this one to base that one, and 4 centimeters or 4 squares for the height. Okay, this is a half a meter, so therefore I will give it 1 square. All right, and then join the 2 ends. Now for the side, I should have written it down. Side, hence is 1, so therefore I need to use 2 squares, and half a meter high, that is represented by 1 square up. Okay, now when you look from this angle here, you'll be looking this rectangle and you'll be seeing another rectangle like this one here, but that rectangle will not be 2.5 meters high, will be as high as this one here, will be 2 meters high, because you're going to stop there at the top of the prism. Okay, so it is very important to the 2 sides, or the 2 pictures, or the 2 drawings have the same height. The same height. All right. All right. Next question is question 4. Right, question number 4 now. We have 2 distances. I'm going to go ahead for this question, add the 2 distances 56 and 61. I do it here, column method. That's 117 kilometers. All right. Now they go on and say, his average speed from Liverpool to Manchester was 70 kilometers per hour, and it took her 75 minutes to drive from Manchester to Sheffield. So basically I need to work out how long it took her to drive from Liverpool to Manchester in the first phase. You see, you got 2 phases. That is the first phase, this one here, and the second phase. All right, and so we're going to do first phase. She did 70 kilometers for 1 hour or 60 minutes. Okay, now I could divide by 10 both of them here, so that is 7 kilometers for every 6 minutes. All right, and from Liverpool to Manchester is 56 kilometers. So you can see 7 is a factor to 56, so I have to do multiply by 8 to get 56 kilometers. That's the distance between Liverpool and Manchester. And you do the same thing here, you times by 8, and I give you 48 minutes. So basically it took her 48 minutes to travel from Liverpool to Manchester. And we also know, we're being told that it took her 75 minutes to drive from Manchester to Sheffield. So let's add up those 2 times. Now we've got the total distance, which is 117 km or kilometers. For the total time, it's going to be 75 minutes at 48. That gives me 13 and 113 minutes. Now when you do the speed, okay, you do distance in kilometers. In this case we want kilometers per hour. Okay, so that has to be kilometers, the distance, and the time has to be in hours. Okay, let me just correct that one. You are right. So this 130 minutes is we need to convert it to a hour, so we need to divide it by 60, and that will give us 2.05 hours. Okay, so basically the speed is 117 divided by 2.05, and the answer we get on the calculator 57.07317. All this recurring, so we need to round it to one decimal place. It doesn't say, but it makes sense. 57.1 kilometers per hour. All right, that's how you answer question for part A. Next is part, right, this is part B. Okay, it does ask us if Janie is correct. What does this tell you about the two parts of Janie's journey? Okay, right, I'll put down here the two journeys from Barnsley to Leeds. The first part 80 and Leeds to York 60 parts. If I did the relationship or the proportionality between the two, so if I did Leeds to York, all right, which is 60, and divided by the journey or the distance Barnsley to Leeds, which is 80, you're going to be end up with a fraction that is 6/8, because you cancel down by 10 and you cancel down by 2, which gives you 3/4. Okay, but I mean, that's what it means. That it means that the journey or the distance Leeds to York is 3/4 of the journey Barnsley to Leeds. That's what my conclusion. Okay, so Leeds to York is 3/4 of the journey Barnsley from Barnsley to Leeds. Okay, so that is the my reply. All right, I hope this helped. Next question is question 5. Right, question 5 is on similar shape, or triangles I should say. Now the scale factor is between this two triangle AE to C and the other triangle, which is BD to C. These are the two triangles, and so we got the E to C, which is 8.1, and you divide it by D to C, the other corresponding side to E to C of the triangle DBC, which is 5.4. The best way is to actually draw them separately, the two triangles. You can see the corresponding sides and so on. Okay, but then if you did this in a calculator, you get 1.5. Okay, that's the scale factor between the bigger triangle and the inside triangle, right? So now to look at the length of A, what is it, A to E, I need to take the length of D to B, if you like. Yeah, it is D to B, so we do D to B is 2.6 and times it by scale factor 1.5, and that gives me a leading of do that in a minute. 2.6 times 1.5, and I say 3.9. Okay, that's the answer. Now we have been told A to C is 6.15. Here's A to C is 1.5. I can go ahead and calculate B to C, right? So we're going to do B to C first, which is going to be 6.15 divided by the scale factor 1.5. Why do I divide, not multiply? Well, because I'm B to C is smaller than A to C, as simple as that. And the calculation will give you 6.15 divided by 1.5. I do get 5.1. And therefore, the length of the side A to B, the one that I'm asking us to calculate, A to B is going to be the longer one, A to C, which is 6.15, minus B to C, which we just calculated now, 4.1. Let's do that. I do get made a mistake, sorry, 6.15 minus 4.1. Okay, that's right, 2.05. That says 2.05 centimeters, and that is your answer. All right. Okay, so this is question 5 done. Now next is question 6. All right, guys. Question number 6 is on compound interest. So we are comparing between two banks, the personal bank and the secure bank. Now I would do the multiplier, just compare the multipliers, but you know, the amount invested is the same, okay, £25,000. So we're not looking to find how much money he or she will, Neil, yes, get at the end of the 3-year period. Just looking for trying to find out which one will give you the most interest. Okay, so for the bank, the personal bank here, the multiplier is 1.02. And because it is over 3 years, right, so you do a power 3. Now if you do that in your calculator, 1.02 a power 3, what do I get? I get 1.061208. 1.061208. That's the calculator answer displayed, all of it in here. All right, so that is that. Let's do what the secure bank gives me. Now the first is 4.3, so that will be a multiplier or what of 1.043, okay, because you do 100 plus 4 and you divide it by 100, so that you get that. And the second year you got 1.009 as a multiplier, because you get 0.9% extra after the first year, right? For each year extra, sorry. And then the third year, so that is the first year, second and the third is the same, 0.09. I could have done squared, okay, but let's do that calculation. And then we'll compare the two results, okay. So 1.043 times 1.009, square it, and equal, it gives me, here it is, 1.061 and then 8584. I'm writing down everything that the calculator displays. 83. That's it, full stop, there's nothing else. Now you can see clearly, not because it's got more digits, right? It's because after the 0, the 10th, the 100th and the thousandths, they're all the same up to here. Right, 061, and then here after the dotted line is 8, and after that is 2. So clearly this one is bigger than this one, right? So the secure bank is the answer. It will give you more interest. Okay. All right. Next question is question 7. Right, question number 7 is on bounds, upper bound and lower bound. We need to write down this number. It is rounded to 2 decimal places. It means to the nearest 100th, okay? And the result is 4.76. The way to do it is write down your number on the number line, 4.76, because it's 2 decimal places. So basically the one before it, it's not going to be the 4 or the 7. It's going to be 4, 7. It will change. So we're changing the hundredths. It's going to be 4.75. And the next number, because we move in, all right, in 100th, okay, from one number to next number. And the after this one, it's going to be 4.77, all right. And then the rest is easy. Just find the midpoint, right, of these two here. That will give you your lower bound, okay. And you can see the number This one here, between these two here, is 4.75 and then 5. Okay? And this one here would give you the upper bound. And that number is 4.76 and then 5. Okay, so our inequality, yeah, we want an inequality. Write it down. N is, this side here has to be less than this number. So this number will not be included, okay, in our inequality, or the values that, the possible values, because if we rounded down, if we rounded 4.765, it would round up to 4.77. All right, so we're gonna say strictly less than 4.765, and write it down properly. Sorry. Okay, and greater or equal than 4.755, and that's is your answer. Okay, next question is question 8. Right, question number 8 is a question on cumulative frequency, and we've been asked to estimate the number of students higher than with a height greater than 160 centimeters. All right, so I went ahead and drawn the line. Here's 160 centimeters there, up till you hit the cumulative frequency curve, and then you project it horizontally against the cumulative frequency axis there, and the scale is 1 millimeter, one unit. So that is the reading here. If I did that, it's 48. So that is 48 there. Now from that is 48. So that's the one we're looking for, not this one, because the one are greater. The people who are greater or got higher than 160 are here, placed here, okay? They are situated here, I should say. So we do basically is 60 minus 48, and that is 12, all right? Okay, next question is question 9. Right guys, this is question number 9. It's quite a long one, but it's all about reflection, okay? First, let's do the first reflection. A in the x-axis to get triangle B, which I've done already, and I already drawn the line of the line y equal x, because we're going to need that later on. All right, so A reflected into the line of x-axis, that gives us B, and then B is reflecting the line y equal x, this one here, to get C. So we're going to do it. So we're going to count how far is from here. This corner, we do a corner by corner, 1, 2, and half. So we're going to be half, 1, 2. Let's check it out again. Half, 1, 2. So that corner, this one will correspond to this one, or the image of this is going to be here. Let's do this one here. This one is 1, 2, 3, and half. Half, 1, 2, 3. And then you can see this one's going to be here. Basically, my reflected shape going to be this one, and this one we call it C, right? So that's we are here. We've done this one, we've done this one here. I may reflect A in the line of y equal x to get D. So A in the line of y equal x to get D. So basically, just that one reflected there. So that one is going to be there, and that one's going to be there, 1, 1, and that one is going to be 1 and half, half. So basically it's going to be let me just correct it. And then that would reflect here, and the hypotenuse will reflect here. Okay, so that is D, right? And then she is then going to reflect triangle D in the x-axis. This is x-axis to get A. So let's do that. So how far is away? 1. If I do this corner, 1, 2, 3. We're going to count 1, 2, 3. that corner there. And that one's going to be, of course, this down here. All right, so let's show the line, that one. Now, what about this one here? 1, 2, 3, 4. 1, 2, 3, 4. That is E. Okay. As say here, Amy says that triangle E should be in position, the same position as triangle C. Let's see. No, it's not. Okay. So we have shown, right, graphically that it's not. Is Amy is correct? Is Amy correct? You must show how you get your answers. That's what we did. We showed all the reflections. All right. I hope this helped. Next question is question 10. Right, guys, this is question number 10. It's going to be a quick one. Question A, or part A, the planet with the greatest mass. All the masses are given in standard form. All of them. What we have to do is just look at the power of 10 here. All right? And you can see Jupiter has got the highest power, 10th power of 27. Next one to it is Neptune, 26, or power 26. Oh no, actually there's Saturn as well, right? But anyway, this is straightforward. Jupiter is the answer to part A. Now, the difference between the two planets, Venus and Mercury, basically you just plug in the numbers or the masses in your calculator and you get an answer in standard form as well. There should be decimal point there. All right, so that's the answer. And you need to say whether Nishat is right or not. Basically, you divide the two numbers, right? And you get, your calculator will give you 105.0724, blah, blah, blah. And so therefore the answer is, because it says it's more than 100 times bigger. So yes, it is. This is more than 100 times bigger. So the answer, it is yes. All right, so that's complete the answer to question 10. Next question is question 11. Well, question 11 is solving an equation. It is a first degree or just linear or simple equation, but it does contain some fractions. We have to deal with them. So the common denominator is 12, okay? So first thing I would do, I would put everything into bracket like so. And like so, okay? That one is slightly wrong, but let me, I want you to a curly bracket. No, I don't want to delete everything. Sorry guys, here you go. Right, so why do I do that? Because I know I'm going to multiply this by 3 to make the denominator 12. All right, so that will multiply by 3. I mean this bracket here, this bracket is going to multiply by 4, and this one multiply by 2, okay, to get the common denominator. So let's do that. We have 3 bracket 3x minus 2 minus 4 bracket 2x plus 5 equal, the other side is 2 bracket 1 minus x. Now I've got everything in the same denominator, so I don't need the denominator anymore. Nice and easy now, straight line. Okay, let's expand and simplify. So we've got 9x here, minus 6. We've got minus 8x, minus 20. Right, so that is the left hand side. Right hand side is 2 minus 2x. Okay, so we're going to do plus 2x. Okay, so we'll have 9x minus 6 minus 8x minus 20 plus 2x equal 2. Okay, and so therefore let's tidy up a little bit, a few things. So I got 9x minus 8x, that is 1x, 1x plus 2x, that's 3x. Okay, we've done the x's. All right, now we have minus 6 minus 20, that's minus 26. Let's write it down first. All right, and that is equal to, so basically we've got 3x equal, if I do plus 26 to both sides, all right, and so that makes it 28 on the other side. So let me just continue here. So I'm gonna do it like this. Okay, so that is x equal 28 over 3, because you divide both sides by 3. Okay, and therefore x equal, it's going to be, was it 7, 8, 9. 9 and a third. 9 times 7 is 27. Sorry, 9 times 3 is 27. Other one is 28. So that's the answer. I would leave it like this or leave it like this. Okay. Okay. All right. So that is the answer to part 11. Nice and easy. Next question is question 12. Right, guys. Question number 12 is probability tree diagram. Now it says here, write down one thing that is wrong with the probabilities in the probability tree diagram. The first two branches here, the first student is straightforward and it's correct. 16 out of 30, 14 out of 60, that add up to 1. Okay, you should know this. And the second student here, if you add up this two here, you get 29. So that must be wrong. Well, it's the denominator is wrong. It should be out of 29. It should be 15 out of 29. Here it should be out of 29. Okay, so let's say the second student for that one, part A. Right, second student. Should be out of 29. Done. Part B, we have some probabilities here. Probability that Owen score in the next match is 0.4. Probability that Wasim score in the next match is 0.25. Mr. Slater says that the probability that both will score goal or a goal in the next match is the sum of the two probabilities. No, you know it's not, because the probability of Wasim or Owen scores and Wasim also scores. Okay, I had written this down too long. Is equal, because you're doing the AND rule. When you do the AND, you multiply, so it should be 0.4 times 0.25. Okay, not addition. So the answer is no. All right, so that conclude the exercise number 12. I think there's no part C. All right, next question is part exercise 13. Right, question number 13. It is on histogram, and I went ahead and worked out some of the scale that I use in straightforward, it's not difficult. The question says 20% of the members of the sports club are who are over 50 years old are female. So we're talking about from this line here, right, and to the right. Okay, that's why I put the solid blue line there. So you should be aware that the frequency is always equal. The formula is basically is the area of that the bar in the histogram. So we need to work out the area of this and the area of this. That will give us the total of members, male and female, who are over 50. So let's do that. Over 50, that is just both gender. Over 50, I meant to say, or I said, I meant to write. So therefore we need to do 10, because this is the width is 10 times the height of the bar is 1.4. That's the frequency density, and we need to add this area to it, which is 30 from 60 to 90. That's a 30 times the height of this wide bar here is 0.7. Now if you did that, you get 35. Okay, yes, and basically it's clearly said here. All right, I circle it. It's 20% of the members who are over 50 are female, so we need to do 20% of 35. Okay, which give you 7. So there are 7 female over age of 50 years old in that club. All right, so that is the answer to question 13. Next question is 14. All right, guys, this is question number 14. It is a question on non-linear graphs, such as a sine or trigonometric graph, cubic graph, exponential graph, and a reciprocal graph like this one here. Let's do one at a time. Now, I do recognize these You don't have to be in order, but for example, I do recognize the exponential graph, which is this one here. Well, there are two actually. There's this one here and this one. This is when the power is positive, like the one we have here. This is when the power is negative. So that is for this one here, A. Okay? And I'm going to tick it so I've done it. Now, I recognize the cubic graph because when x equals 0, it will have 0 there, right? There is no other cubic graph I can see in here. So the only one is f. So that one goes for this one here. Now for the reciprocal, again, they look like this or like this. Either B or H, which one? Now this one is for the positive x's, right? When x is positive, y is positive. When x is negative, y is also negative. So it has to be this one here, H. Okay, so this one is reciprocal, but this one is minus x. Okay, we have a minus before the fraction, so that's not the one we're looking for. Okay, although it is a reciprocal. Finally, the sine x, which one? Now, it can't be this or this or that. So either this one or this one. If you know that sine 0 equals 0, all right, then you're good to go, because that is sine. This is when x equals 0, the angle is 0, the value is 1, you know, the plus and minus 1, the maximum and minimum. So it has to be this one here, C. All right. Okay, so that's the answer to exercise number 14. Next one is question 15. All right, question number 15. It is a question on the circle theorem, and also involve a similar shape. We've been asked to show that triangle ABE is similar to triangle DCE. Now, what I did is I went ahead and drew the circle again, but drawn it exactly as it is, but without the side A to D and the side B to C. Because I realized there's one thing here. There are some, in order to prove that two triangles are similar to each other, you need to show that all the corresponding angles inside these two triangles are equal to each other. And with too many lines, it's a little bit confusing, and it doesn't allow you to clearly see what's going on in that circle. So I went ahead and moved that side and that side. Now what we left is angles in the same segment, this one here, B and C. Can you see that in the same segment that are equal to each other? I narrowed down the reason. Angles in the same segment are equal. So B to C is equal. Now we have the angle E, which is shared by the two, or common to both. And we have also another two angles in the same segment. These are angle A and D, so therefore they are equal. So we have established all the three triangles, all the three angles in the two triangles are equal. We're talking about the corresponding angles are equal to each other. This one corresponds to this one, and this angle here corresponds to this one, and that one corresponds to each other because it's the same one anyway. So therefore, straightforward, the two triangles are similar to each other, and that's how you do it. All right, so next question is question 15. Sorry, this is question 15. Next question is question 16. Right, question 16, we have question on recurring decimal numbers. A bit unusual questions because you have to use algebra to show that this multiplication of these two recurring decimal numbers is equal to 1 over 33. To be honest, I've never seen anything like this before. Okay, now we know how to convert a recurring to a fraction, all right? Because what I'm trying to do here, because well, I can see the answer and the result is going to be just a normal fraction, so we need to change this to recurring decimal to fractions first, and then multiply them, and then simplify, and then and then we get answer. That's the idea I'm thinking of. All right. So and anyway, we do use algebra to convert a recurring decimal to a fraction. You know the method. So you call the first one here, we call it x is equal 0.13636, right? We write it down without the recurring dot point there at the top of the 2 digits. So next, because we've got 2 digits recurring, so we need, is this 2 here, we need to multiply it by 100. So we need to make 100x. So that's algebra already. Okay, so move the decimal place decimal point, 2 places. That would give us, let me think again, it's 13.6363 and so on. Just make sure you get it right. Okay, now and then you do you subtract this one from this, right? So you do minus x or some similar method anyway. So you get you place it here 0.13 and then 63 and so on. So then you end up with 99x. All right, which when you subtract in this sign here, the algebra part, algebra part here, or side, it says 13 minus 0 is 13, and you can see that 6 minus 1 is going to be 5, and everything else will turn to a 0. 3 minus 3 is 0, 6 minus 6 is 0. 3 minus 3 is 0. So they will eliminate each other. So I'm going to just cross them like this. So the answer is 13.5, sorry. Okay, so that is down. So I can write down as x, all right, I write it down here. For the first one, for this one here, is as 13.5 over 99. We agree with that, don't we? Now I don't like this decimal number, so I'll do just a little trick, you know it. You times by 2, because any number you multiply by 2, or decimal number like this one, not all of them actually, it turns to a whole number, 27, right? And this one's going to be 198 at the bottom, or at the denominator. So let me just double check. That's 180 times 19. Yes, it's 198. Now I could cancel it down at this stage, but I'm going to leave it like this for now. Okay, we'll cancel it down later, hopefully. Now let's do the same thing for the other one. I'm going to call it y, so to avoid any confusion. Okay, here is 0.2 recurring and so on. You know, there's only 1 digit recurring, so we multiply it by 10, don't you? All right, yeah, you know that. So you're going to 2 and so on. Okay, and then maybe I need to add another one. So then you subtract this from this. All right, so you do minus y, and which is 0.222 and so on, and you get your 9y equal just 2, because everything else will cancel out except 2 minus there's 2. So basically we got the other number, y equal 2 over 9. So what we need to do now, basically we're multiplying this to recurring decimal number is the same as multiplying these 2 fractions, because they are the same, aren't they? What I'm trying to say is that this fraction is equivalent to this recurring decimal number, or it is exactly the same value. Means that if you grab your calculator and perform this calculation, or type in this calculation, 27 divided by 198, you get 0.1363636 and so on, and the same thing for this one. So basically multiplying these two is multiplying these 2 fractions. So let's do that. So I'm going to just write it here, just 0.136 recurring times 0.2 recurring is the same, I'm just equal as 27 over 198 times it by 2 over 9. Now you can see there's a lot of things we could do here. We can simplify, we'll cancel down by a 9. That gives us 1, we'll get divided by 3. I can cancel down the 2 here by with this one here. Divided by 2, that gives me 99. Let's write down what we got so far. I'm going to jump to this line here. So we've got 3 times 1. At the top of the fraction is 1 fraction now, and 99 times 1. Look at that. I got 99. Right, it is a 99 there. Over 99. And then divide by 3 again. Divide by 3. To get I will answer 1 over 33. I think I've done it. Okay, I think that's how you do it anyway. We use a lot of algebra X and Y, and that should please the examiner. Right guys, question number 17 on the area of sector of a circle. The formula for that one, you should know it, you are aware of it. It's theta over 360 degrees, and you times it by pi, times it by r squared. Now we have r squared, which is 11 squared. Now the problem is, it's not a problem, but it's angle theta. Actually, in fact, angle theta is 60 degrees. How do I know that? Because it tells me here the triangle is an equilateral triangle, and we know angles inside an equilateral are 60 degrees. So this one is 60 degrees, and it is also shared by the two, the sector and the triangle itself. So let's put it in 60 degrees over 360 times pi times 11 squared. Let's do some cancelling down here. We've got 6 divided by 36, which is 1 over 6, and times pi and times 121. So let me just rewrite it slightly in a nice way. What I mean is just bring the 121 front of the pi over 6. I'm going to leave it like this as an exact value. I'll do the calculation later. Now I need to go and find the area of the triangle, because I need to deduct, subtract that one, if you like, or deduct that from the sector. So let's do that. We're going to use the formula half AB sine alpha, where alpha is my angle 60 degrees, A is the side of the equilateral triangle, 7 centimeters, and B is the same thing, 7. So basically we've got half 1 over 2 times 7 times sine 60 degrees. All right, let's do some calculation. 7 times 7 is 49 over 2, and sine 60 is square root of 3 over 2, and this will give me 49 square root of 3 over 4. Again, I'm going to leave it like this. So the area of a sector is, it's going to be 12, oops, sorry, I apologize. It's going to be 12 pi, it's not 12, it's going to be 121. 121, I wrote down 112. 121 pi over 6 minus 49 root of 3 over 4. Now, in order to give the answer as a percentage, I need to divide it by the total area of the sector. So I need to do all this divided like this over 100, same one as this, 121 pi over 6, and I time the answer by 100. Okay, that's why you need to time it by 100 to convert it to a percentage, right? And once you've done this in your calculator, you will have the answer 66.5%. all right guys, I hope this helped, and I hope it's been clear enough for you to follow, and I hope the pace of the explanation wasn't fast or too fast. All right, next question is question 18. Right guys, question number 18 is question on indices and fractional powers. Now, when you are dealing with this type of question, you have to remember that you have to have everything in the same base, right? So what do I mean by the same base? Now, if you take a to the power of x, I mean the base here is a. Let's do a numerical number, 3 to the power of let's say 5. The base is 3, okay, and this is the index. So now you can see this is a base 16, this is a base 2, and the other side 8 is a base 8. Okay, now you may ask, what should be the common base? Well, you need to have always, mostly is the smallest number, as that is the base. In this case, I don't know if it makes sense to you, but the base 2 is the smallest. You have to bring it down to 2. For example, 16, you can write it down as 2 to the power of 4. You can see the base is 2. Right, 8, we can write it down as 2 to the power of 3. The base is 2 now. So we've got our bases 2. Let's go and replace them and change the expression. So 16 becomes 2 to the power of 4. I'm going to introduce a bracket because I have a fractional index or power outside. So that's how you do it. Now times 2 to the power of x. It was already base 2, and the other side 8 becomes 2 to the power of 3 and a power of 3/4. All right, so what do I do next? We're going to use that rule or the third rule or the power rule, I think that it's called. If you have a to the power of m and then n outside, I call it myself power of power. You just multiply the two powers, right? That's, oops, sorry. You do it that times n. So therefore we're going to do the same thing here. We're going to multiply 4 by a fifth. Now we do 4 times 5, right? That's easy to do. You multiply as if you are multiplying fraction. 5 over 5. You can do it monthly. You don't have to do all this working out. It will give you 2 4 over 5 times 2 to the power of x. Nothing happens there. And the other side, we're going to do 3 times 3/4. I'll write it down here. But you don't have to again, just to illustrate. You do 3 times 3 is 9 over 4. So the answer is 2 to the power 9/4. Hang on there, we haven't finished. There's still some work to be done. Now I've got all the bases the same as 2. I can go ahead, for example, simplify this. If you have 2 to the power m times 2 to the power n, you know, you add the powers. This is one of the basic first rule of indices you learned in school. So that's what we're going to use here. We've got fraction x, the power with the rules still apply. So we're going to do 2 to the power 4 over 5 add x equal to 2 to the power of 9 over 4. As you can see now, for this equation to be true, the powers have to be equal to each other because we already got the base equal to each other. So we're going to say 4 over 5 plus x is equal to 9 over 4. Now all we have to do is just solve it for x as you would with any simple equation. You can see the common denominator is 20. So let's go ahead and do that. We're going to multiply by 4 here. So we do 4 by 4. And here we're going to multiply by 20. You get 20. And here I'm going to multiply by 5 to make it out of 20. So let's write it down. I'm going to do a bit of rubbing off or tidying up on my board, okay, because I need some. So now we've got everything after 20. So for this one is 16, right? 4 times 4 is 16 plus 20x equal 45. Now you don't need the denominator, so we do minus 16 for both sides. So we have 20x equal, what is it, 29? 45 minus 16 is 29. And then therefore x will be equal 29 out of 20. And that is your answer. Now you have the choice to write it down as a mixed number or a decimal number. It's up to you, but I'm going to leave it like this. It should be fine. And that's how you answer question 18. Next question is question 19. All right, question 19 is on algebraic fractions. Right, so let's get started. First thing you need to find out is the common denominator. Right, and our common denominator, sorry, is obviously you can see clearly is the product of these two here, these two denominator. So it's x minus 3 and times x plus 3. Now that one there, 2, we're going to have to multiply it by both. 2 here, the two brackets, minus 3, x plus 3. And then you've got minus k. Now this bracket here, x minus 3, which is this one here, it has to be multiplied with x plus 3. So we're going to put this into bracket, right? Plus 2, and we'll time it by, we said x plus 3. And we've got minus that bracket, x minus 6. Well, it is not a bracket, but we have to put it into bracket. This is x plus 3. That x plus 3, so we need to multiply by the other one, the x minus 3. Sorry, I meant, I need to do, okay, let me start off this. Okay, it's x minus 6. And we need to multiply it by x minus 3. Okay, all that, right? And the one fraction, it's going to be this x minus 3 bracket x plus 3 close bracket. All right, so when you expand that, these two double bracket, you get x squared minus 9. So we've got a lot of work to do at the top of the fraction. All right, now these two are nice and easy, same as this one here. So let's write it down. So basically you do 2 times x squared, which is x squared, minus 2 times 9, which is 18. Right, what else have we got? I'm going to keep these two here in bracket, and then I will remove the brackets. Just copy this down. Okay. Right, now let's expand this one here. You've got x squared. You've got 3x and 2x, that's 5x. And then plus 6. Here we've got minus and minus, all right? So we've got x squared, we've got minus 3 and minus 6, that's minus 9x, and positive 18. All right, let's jump a line. So we're going to do 2x squared minus 18. Now I'm ready to remove the brackets. So minus x squared minus 5x minus 6. Now what else you got in minus x squared plus 9x minus 18, all that over x squared minus 9. Right, let's simplify. You got 2x squared minus x squared minus x squared. Wow, so all these will cancel out. Okay, the 2x squared minus x squared is 1x squared. 1x squared minus 1x squared is going to be 0x squared. That will eliminate. Okay, that's what I mean. Right, let's do, just copy this down here, the denominator. Let's do the x now. We've got 9x and we've got minus 5x. I think that's all we've got. 9x minus 5x, that's 4x. Right, let's cross them. And then we've got minus 18 minus 18. That makes it minus 36. Okay, and that is your answer. So basically A is equal 4 and B is equal minus 36. All right, does it cancel down? I'm just thinking no. All right, so that's the answer. Next question is question 20. Right, I'm back. I just realized there's a minus 6 here. So minus 18 is a minus 36, and minus 6, that makes it minus 42. Okay, let me rub it off. Okay, so minus 42. Always double check. That's what I was doing, doubling checking. All right, so that's the answer to question 19. Let me just correct that. B is minus 42. Minus 42. All right, so that's the answer. Definitely, this is the answer now. Okay, question 20 is next. All right, question number 20. It asks, by drawing suitable straight line, use your graph, this one here, the given graph, to find an estimate to the solutions of x squared minus 3x minus 1 equals 0. Now this graph is for this function there, for this expression, okay? how do you get from here to there? Okay, so basically this is made up of this quadratic expression plus another one. Let's break it down. So first thing you need to do, write it down. Minus 3x minus 1 equals 0. Remember, we need to extract this expression from this. Right, x squared is x squared, so no problem. Same, there's nothing to extract there. Minus 3x is made up of minus 2x and minus x, right? So if you add this 2, it gives you 3x with a minus sign. Now, for minus 1, to get from minus 1 to this, you need to do plus 4 minus 1. That will give you 3. All right, let's recap. The minus 3x is made up of minus 2x and minus x. The minus 1 is made up of plus 3 is made up of 4, minus 1. Okay? Right. So, now we make it equal 0. And then x squared minus 2x. The ones we don't need is this one here. We're going to have to move it to the other side. And we need to move. I made a mistake. It should be plus 3. I need to have plus 3 to create this graph. Right, let me just go back. Sorry, guys. Okay, it shouldn't be difficult. Right, I need to have plus 3. I need to have plus 3 to create this graph. But I need to have a number, add a number, so that I will be, the answer or the sum will be minus 1. And that number is going to be minus 4. Okay? All right? Now, let's rewrite it. X squared minus 2x, this one here. I'm going to put the expression for this graph, separate it from the new expression here. Minus x minus 4. Plus 3 equal, I'm going to move this to this to the right hand side, become well, just x or plus x. And this one here also it's going to move to the other side. It will change to plus 4. And that's why I had this line here, x plus 4. So, and that's what they mean by drawing a suitable straight line, this one here. So the straight line is x plus 4. Okay? Now when you draw it, would you need, and I mean when you draw this straight line, would you need a table of numbers or values? Right? You don't have to. You can just give two values, maybe 3. If x equals 0, y equals 4, that's the one there. If x equals 2, y equals 6, that's what I got there, marked it. And I did x equals minus 2 to give me y equals 2. And you got the 3 coordinates or 3 crosses, and you join them with a straight line. All right, that's make sure that your straight line crosses the curve, because the solutions to this expression or equation, quadratic equation, it's going to be this one here. All right. I think I'm doing it right. I hope so, but I think I'm doing it right anyway. So it's this one here. We can come back and read them, and the other root is going to be this one here. Okay. Right. So let's do the first one. We have x1 equal. This is 2.5. It looks like 2.7. I'm going to go for 2. So I apologize. 2.7. This is 2. This is 3. It's going to be 3.2. Roughly 3.2. Okay. X2 is going to be here. this is 1, roughly halfway. I'm going to go minus 0.4. Right, these are my estimated answers. Okay, it says estimate. Okay, so all your answers, and because they are worked out or you find them graphically, so therefore we call them estimates. All right, that is part A. Let's do part B now. Right, part B. P is the point on the graph. Y equal x squared minus 2x plus 3, where x equal 2. You could draw the line x equal 2, and where it meets the curve, that is your point P. Right, I've done it here. Now at that point you need to draw a tangent to work out the gradient at that particular point P. Right, so now you draw a tangent, all right, and you have straight line. Then you do the right angle triangle method to work out the gradient. So you calculate the change in y, right, which is this one. In this case is it goes from 1, because that value there is 1, to 6. Okay, so that is a change of 5, and you divide it by the change in x, so it goes from 1 to 4. Okay, so that is a change, okay, over 3. Okay, so that's 5 over 3, and that 4 gives me 1 2/3. Okay, we can leave it as 5 over 3, that's fine. That's the answer. We can say m is equal to 5 over 3. Or you can write it down as roughly 7 or 6 recurring. So that's how you answer part B of this question. All right, next question is question 21. Right, question 21, we have a rectangle and there's 3 circles inside it as described in this exercise. Go ahead and read the question fully and follow my answers and working out. Now the area of a rectangle, you know it is width times the length. Now the width for this rectangle is going to be the width of all the radius, or the width of the radius or radii add together. So that is first radius, radius number 2, radius number 3, radius number 4, if you know what I mean. 1 2 3 4. So basically it is 24 times 4, which is give you 96. Right, we'll leave the units for now. So that's 96. The length is not as straightforward as the width, because you see the length, you got this radius and this radius, but this radius overlap with this radius. Okay, so to calculate the length of this one here, you need to do radius, that one. So from there, we'll do 24, and we got another one. We need to do this height here. If I draw a straight line, so that one would be, we call it H. Yeah, I'm gonna put it a straight line like this. So we need to add that height, sorry, or H. And we got finally this radius there, which is 24. Let me change it slightly, which is 24 basically. So we've got a radius at the bottom, radius at the top, and height at the in the middle. Okay, now how do I work out the height? That is the key for this exercise there. right? Now the height is inside this triangle. Now you need to realize that this triangle here is an equilateral triangle, which I have drawn here, a bigger size of course for better illustration. The height is the one we are trying to figure out, okay? And you can see the height always makes 90 degrees. It has to be perpendicular. Now you realize this side here, or this side, or this side, the three sides actually, they all join the centers of the circle. So for example, if I look at the base, which corresponds to this one here, made up of two radii, which is 24 and 24. So basically this half here is 24 only. All right, I hope that's clear to you. Now what about the hypotenuse, because we're going to need that, okay? The hypotenuse, we're going to need it. Do you see also join these two centers there? So it's made up of one radius plus another radius. So basically this hypotenuse is 48. Okay, it's 24 and 24 because one radius is 24, so two radii is 48. Simple. All right, so we got the hypotenuse, we got the base. I can work out the height. Let's label it h using Pythagoras equation. All right, so let's do that. Okay, so I went ahead and did the Pythagoras, which is h squared equal hypotenuse squared 48 squared minus the base 24 squared, and when you square root everything, it gives me this answer. You may be wondering why didn't I give it in decimal number. Well, the calculator gave it to me. It's fine by me because at this stage I do not want to round anything. It is best, that's a rule of thumb, to leave the rounding till the end. Okay, so that is a really a good practice. Okay, so try to use that. So we got h. Nice. So what is the length? Let's go back to our length. This one here, or this one, it's going to be 24 and 24, which is 48. Add the height, which is 24 square root of 3. Now, do I need at this stage to calculate it, give it as a decimal number? No, no need. Okay, just plug it in your calculator like this and times it by 96. So I'm going to write it down here. I'm going to 48 plus 24 root 3. We can plug it in your calculator like this, and you get something like this: 8598.645061. Oops, 61. All right. I left the decimal point somewhere after the 8. That should be there. Okay, and of course the unit we're using is millimeter squared. All right. Now we need to give you answer our to 3 decimal places. Sorry, 3 significant figures. So let's count 1, 2, 3. That's the 4th significant figure. So it's more than 5. So this one has to go up. Okay, it becomes 100. So therefore we could, well, it becomes 100, yes, because this tens becomes 100. So therefore this one is going to be 6. So basically an answer, you know it is 600. And oops, I was going to write down centimeter squared. No, the answer, the unit is millimeter squared. Okay, so it's interesting. It is an interesting exercise. That's how we do it. Okay. Next question is question 22. Right, question 22 is on sequences. Let's have a look. 4, 11, 22, 37, 56. Right, the difference here is plus 7. The difference here is plus 11. The difference here is plus 15. And the difference here is plus 19. Right, so it's not a linear sequence. So we need to do the second difference. I'm going to change color. Blue. The difference here is plus 4. the difference is plus 4 and plus 4. Now we've got a constant difference, so therefore we know our sequence is of the form quadratic an squared plus bn plus c. All right, as a trick or shortcut or rule, if you like, a is always equal the last difference or the constant difference divided by 2, or half of it. So you do 4 divided by 2. So basically a is equal 2. Now the question is, how do I find b and c? Well, it's by just substitution, because n is the position of each term, and we know those terms. Okay, so let's say for if n equal 1, all right, we're going to put it in here, we'll plug in here. So it's going to be I forgot, by the way, because I've got a equal 2, so I can write it down as 2n squared plus bn, it's not a big deal, plus c. So n equal 1, I'm going to plug it in here or substitute it here. So it's going to be 2 n squared is 1, so that is 2, plus b times 1 is b, plus c. Now the first term is equal 4. So that gives me b plus c is equal, you do minus 2 both sides, equal 2. That's my first equation. I got 2 unknown, 2 numbers to work out, so I need to have 2 equations to solve, simultaneous equation. Let's do another one. You don't need to go far, just n equal 2, right, and then plug in 2 in here. So it's going to be 2 squared, which is 4, 4 times 2 is 8, plus 2 times b, that is 2b, and plus c, and the second term is, when n equal 2, is 11. You do minus 8 for both sides. So that gives you the second equation, which is 2b plus c equal 11 minus 8 is 3. That's my second equation. Now I'm going to do 2 minus 1. I'm going to write it down here, 2, the second equation, minus the first one, and that will give me 2b minus b is b, and the c will eliminate. Yeah? And 3 minus 2 is 1. So therefore, we got the second term, b equal 1. Let's write them down here. Well, actually here. Sorry, guys. 2b is equal 1. We need to work out c now. Well, c is easy if I go back to the first square equation, the easy one. So c, well, 1 plus c is equal 2. So therefore, c is equal 1. All right? So that is c. Now we've got all our values, a, b, and c. Let's put them in our expression, because it's going to be like this. So the expression is 2n squared plus 1b, or sorry, 1n, apologize, or just n plus 1. That is your expression for the n term. You can check it out by, for example, putting n equal 3, you should get 22, all right? So let's do it together. 3 squared is 9, 9 times 2 is 18, 18 plus 3, that is 21, 21 plus 1 is our 22 there, okay? So that's how you do quadratic expression. Okay, next exercise is, or question is question 23. All right, question number 23 is a tough one. It will take us more than 10 minutes to complete it. I'll try my best to not skip any steps. Okay, it is to do with perpendicular lines. It is to do with equation of straight lines. It is to do with gradients, and it is also to do with equation of circle. All right, now this one here is the equation of the circle. What does it mean? It means that this circle, as I've drawn it here, has a center O, 0, 0, the origin, and the radius 2, okay? The radius in the red. Now, so I had and drawn the 2 axes and the circle at the center of the X and Y axis, all right? So the point P doesn't matter, it's just illustration. It's 3 over 2 across, and root of 7 over 2 up on the vertical, but I placed it here roughly there. And then the line, the tangent is going to be at that particular point. So I went ahead and draw it, which is represented by this blue line here. T means tangent. Now you should know that, I'm sure you do, a tangent makes a right angle with the radius, okay? All right, so that is the first thing. So therefore, in order to work out the line with the equation of the tangent T, you need, write it down, find the gradient of that line. We're going to call it m prime or m dash x plus c. Okay, you understand why in a minute. Okay, now the gradient, because these two lines, the blue and the red, are perpendicular, so their gradient m, that is the red one here, right, the gradient of the red line from O to P, times the gradient of the tangent, that is m prime, is always equal -1. All right, this is a fundamental rule that you need to know in order to be able to tackle this type of questions. What else do we need to know? We need to be able to work out the gradient of the red line, right, or the radius there. Okay, so that line is going from the origin, which is 0, 0, and is joining to P, which is 3 over 2 and square root over 2. Okay, so if you have 2 points, okay, you can calculate the gradient of these 2 points. Okay, you're familiar with the formula. The gradient is x2, not x, the change of y, so that's y2 minus y1 over x2 minus x1. Now for x2 and x1, doesn't matter which one is which, right? So we're gonna start from here. That is my y2, okay, this is my x2, this is my y1, this is my x1. So I need to do that minus that. Let's do it. So the gradient m, that is for the red line, okay, is going to be root of 7 over 2, that's y2 minus y1. I'm following the formula, minus 0, because y1 is 0, okay? And then x2, which is 3 over 2, minus x1, which is 0. So basically, m is that divided by that, okay? Surely you can understand that, because fraction is the same as division. And surely you know how to divide fraction. You have to go through this process. So you do root of 7, and then you change the divide to multiply, and you flip the second fraction, which becomes 2 over 3, and that would allow you to cancel the 2 there. So basically the gradient, let's recap. I'm going to write it down here because I think I needed more space. All right, m equal root of 7 over 3. That is my m for now. So what's the point of calculating the gradient? Well, because this formula here, if I know m, I can work out m dash. That's why I need that, and then I can go and find c, the intercept, and that would complete finding the equation of the tangent. All right, so let's find m prime or m dash. That is the gradient of the blue line. So in order to do that, you do -1 over the gradient m. Basically you do the reciprocal and you times it by -1. That's what it is. And the reciprocal of root of 7 over 3, you know it is 3 over root of 7. And let's not forget, we time it by -1. So that is m dash, okay, or m prime. Now, having it like this is not such a good idea. You need to rationalize it. You need to make the denominator as a whole number rather than the third. So we need to, how to rationalize. Square root of 7 times the root of 7, square root of 7. That will give you -3 root of 7 over 7, because when you multiply these two, you rationalize the denominator, it becomes 7. So this is finally my gradient for the tangent there. I'm halfway, nearly there. Now how do I find the intercept? Let's first write down the equation, because we're halfway there. So y for the tangent, maybe I should write it down in blue, why not? Okay, let's do it. So now y is equal that minus 3 root of 7 over 7 x plus c. Alright, how do I find c? Usually, some of the questions that you've done in classwork, you would have the tangent or the grade or the whole diagram in maybe a grid where you could just read it off from the y-axis, because that's what it is, say there, the intercept. But you can see here it's not going to be possible. All right, we've got nothing, no scale, nothing, so we have to do it algebraically, and that's why the problem starts now. So as if this is not problematic, okay, or not hard enough. So how do I find c? Well, the line, the tangent, sorry, yeah, with the line goes to the point B. What does it mean to us? Well, basically it means when y is equal root of 7 over 2, let's write it down, root of 7 over 2, it means that x is equal 3 over 2. That's what it means. So we need to substitute them. All right. So you see now we've got an equation, not an easy one, because you've got the third here, square root 7, you've got 2 there, 7 there. All right. We need to solve it. All I have to do is just solve it for c. So let's do it now. What I'd like to do is just try to tidy this up first, okay? I know 3 times 3 is 9, okay? And so basically I would have minus 9 root of 7, and the denominator you need to multiply 7 times 2, because this is a multiply after all. Think of it as when you multiply two fractions, and that's what it is exactly. So let's write it down. I'm going to jump here because I don't think I'm going to have room here down here. All right, so I'm going to just start here. So I'm going to kind of draw a box. All right. So basically, we've got on the left-hand side, it hasn't changed yet. We've done nothing to it so far. We'll come to it in a minute. I'm just focused on this one, as I said. So it's minus 3 times 3 is 9, root of 7, over 7 times 2 is 14, plus c. Now you can see the common denominator now is 14. So therefore, we're going to need to multiply this by 14, the c. We need to multiply this one by 7. So we have 7 here. And then we get rid of the denominator. It should be at 14 as well here. Right, so that is very good. So let's do it. 7 root of 7. Okay, that's what it is. 7 root of 7, or times the square root of 7, equal minus 9 root of 7 plus 14c. Now I need to make c the subject, or I'll just solve it for c. So you can see this is same. Well, this is 7 root of 7. This is 9 root of 7, or negative. But in order to move it to this side, you need to do plus 9 root of 7. The same way as you would do it with normal whole number or integers, okay? So we need to add plus 9 root of 7. That is a plus, sorry if you didn't come up clear. Right, so therefore we got 7 plus 9. Think of it as 7x plus 9x. You get 16 root of 7, or square root of 7. And these two will cancel out, but you still have 14c there. Right, I'm going to just flip it around now. So basically 14c is equal to 16 or square root of 7. So therefore c is equal 16 root of 7, or square root of 7, over 14. let me just move up here, sorry guys. C, therefore I need to cancel down these two here, divided by 2 to give you 8/7, root of 7. Wow. Okay, so therefore we got the C, and we have the gradient, of course, this one here. All I have to do, just find a room where to write my my equation. All right, I'm gonna write it down here. So the equation for the tangent y is equal, let's not forget, start with this one, yeah, minus 3 root of 7/7 x, and it is a positive C, yeah, all this one here, plus 8 root of 7/7, and that is your beautiful equation for the tangent. You may be tempted to take root of 7/7 outside and factorize it. You've done enough. You don't have to do all that. Trust me, in the exam they won't ask you for that. Okay, this is the last question. This is a tough question. It's not an easy. We finished this paper 2. Next will be paper 3. All right, thank you for watching this video. Take care guys, thank you for watching. I'll see you in the next video.